Welcome back, everyone. Data voice and video cabling, Chapter 10, the wiring termination practices. Once again, as we always start off, what do we hope to get out of this chapter? Well, to learn the termination process for coax and twisted pair cables. The purpose of this chapter is to show you how to handle and terminate cable for telephone, LAN, CATV, CCTV, video networks, and all the tools and materials needed are described in detail to allow you to follow these directions and learn how to properly install and terminate cables. To get the most out of the exercise in this chapter, you should already familiarize yourselves with data voice and video wiring by having studied the earlier sections of this book. Now, this chapter covers both coax for CATV, CCTV, and unshielded twisted pair wiring for LANs. So let's get started. In this section, we're going to concentrate on installing connectors, the most critical part of the coax cable installation. All cable TV, community antenna TV connections are made with F-type connectors, along with the B and C bayonet connectors. Now, the F connector is a screw-on or crimp coax connector that uses the center conductor of the cable as a contact, and that crimps or screws on the cable jacket and shielding to make contact with the connector body. Now, the screw-on F connectors are often used to make up cables to go from the CATV wall outlet to the TV, but the quality of these connectors may allow signal leakage or reflection. They're not recommended for usage in permanent wiring. Crimp-style connectors should be used instead. The crimp-style connectors use two techniques. Normal external crimp connectors use hex or six-sided crimp jaws to compress the connector body around the cable. Compression style crimpers produce round or tighter crimp with full crimping of the cable with less signal leakage. The most common for the CATV premises wiring is a coax cable known as RG6. It is a large center conductor surrounded by a plastic foam dielectric that is covered by a metal foil, then a woven braid for the shield, and finally a jacket of insulated material appropriate for the locale of the installation. For the exercises that we'll be doing, you need a coax cable crimper and the crimp tool with the proper coax connectors or jaws that are installed. Okay, the strippers, prepare the cable for termination by cutting all the outer layers of the cable off to expose the center conductor and then removing the jacket to allow the connector body to make contact with the shield. There are several types of strippers exist. One is an adjustable stripper that can make several simultaneous cuts to prepare a coax cable for termination in one step. The cutter must be adjusted for the cable type being stripped. If the cable is not being stripped correctly, you'll refer to the instruction manual for the stripper information and then adjust the cutting blades accordingly. The crimpers, or the crimper clamp, it clamps the connector to the cable permanently. Most crimpers have hexagonal crimps sized for each connector type and replaceable jaws for different connectors. A unique set of jaws is needed for F coax connectors, B and C connectors, and UTP modular connectors. So make sure the proper jaws are installed in the crimper before use. Most crimpers today are ratcheted, so that once a crimp is started, you must completely cycle the crimper to ensure the crimp is properly made. These crimpers usually have a release lever to bypass the ratcheting. So it's a good idea to find the lever and make certain you know how it works, just in case you need to abort a crimp. Using the coax cable stripper, you want to insert the coax cable into the stripper and then rotate several turns to make the cuts. Pull the cable from the stripper and it should be ready for termination. Examine the cable carefully. Note the center conductor that also has the center pin of the connector, and see how the foam dielectric separates the center conductor from the shield, and how it is covered with a foil layer that also assists in shielding the cable. Note the woven shield from the foam should be slightly woven to prevent signal leakage. So the process of attaching the connectors are as follows. Use the coax stripper on the cable to strip the cable for termination. The outer insulating jacket must be stripped away, exposing the braided shield. The braided shield must be pulled back over the outer jacket, leaving the inner insulation and its foil shield exposed. The exposed center conductor should be checked to make sure it is clean. The connector is then placed on the end of the cable and crimped or tightened down. Installing the coax cable is relatively simple. Coax cables must be installed with care. They may not be pulled beyond their tension limits, and they may not be sharply bent. In addition, they must remain safe from physical damage and from environmental hazards. Care must also be taken when strapping or especially stapling cables to structural surfaces like walls, ceilings, and so on. Special staples are available for coax cables. If the staple or strap is cinched too tightly, it will deform the cable and alter its transmission characteristics. If the staple or strap is overly tight, the system may not work properly or even at all. Perhaps most important with CATV cables is the proper cable selection and termination. CATV cables are directly connected to the public CATV network. The FCC rules limit signal leakage, so it's important to use good cable with proper shielding and to terminate properly in order to prevent signal interference with other electronic devices. In addition, poor termination can cause reflections in the cable that affect the return path or connection back to the system. Because more networks are upgrading to a greater number of channels or programming usage, or are planning to use cable modems for internet connections, proper CATV installation has become more important. Next, we want to discuss Cat3, 5E, or structured cabling. Now, most commercial installations use Cat 5E or 6 wiring for LANs in Category 3 and 5E for phones. Most new or rehabilitated construction will install the cabling closely following the TIA 568 568 with 2 UTP cables per work area. Sometimes a Cat 5E cable is used for LANs and a Cat 3 is used for telephone, but today 2 Cat 5E cables are most often used. Cat 5E UTP cable and all the hardware associated with it are designed for LANs operating up to 1 billion bits per second or a gig. Although most of today's LANs are operating at 100 meg, most users assume that at some future date they will upgrade to the higher bit rates. Therefore, it is necessary to install network cabling properly and test for Cat 5E or 6 specifications. In order to ensure that Cat 5E or 6 performance throughout the network cabling, it is very important to use only Cat 5E or 6 hardware, including the termination blocks, the jacks, and plugs, and to follow installation procedures rigorously. Sloppy installation practices will degrade the Cat 5E or 6 components to Cat 3 specs. Numerous articles in the trade have said that as many as 80% of all Cat 5 installations did not meet Cat 5 performance specifications. The key to Cat 5e and 6 performance is maintaining balanced transmission over the controlled twist of the wires. At every connection, it is mandatory to maintain the twist as close to the connections as possible, never allowing the pairs to untwist more than a half an inch. In addition, the twist can be damaged by pulling the cable too hard. The specification for pulling tension is only 25 pounds. And as part of this exercise, you will pull cable with a scale to see how little tension this is. Now, Cat 3, 5, and 6 are made of 4 twisted pairs, 22 to 24 gauge copper wire. LAN cabling is a solid wire, but patch cords are usually made of stranded wire for greater flexibility. Each pair is twisted at a different rate and is color-coded. Take a sample of Cat 5e or 6 cable. Strip off about 2 to 4 inches of the outer jacket. Spread out the 4 pairs and note the color coding and the differences in the twist rates of each pair. If you look closely, you can see the differences in the twist rates. Now, strip off about 2 to 4 inches of the jacket of the Category 3 cabling and examine those pairs. Note how little twist is present in the Cat 3. The main difference in performance of Cat 3 and 5 and 6 is the twist rate and the consistency of the twists. To terminate these cables, you need to separate the wires, order them in according to the proper color code for the type of connection that's being made, and then in addition, it's imperative to maintain the twist of each pair of the Cat 5 and 6 cables to within a half of an inch. It's important not to stress the cable more than necessary when pulling. The maximum pulling tension for Cat 5 and Cat 6 is 25 pounds. The performance of the Cat 5 and 6 cable is determined by the careful construction of the twists in the pairs. Excess tension on the cable may change the twist in the cable, causing an increase in crosstalk, attenuation, or impedance. Oddly enough, a tension of 25 pounds is actually not very much, and sometimes cable is installed in conduit where the pulling tension can get quite high if there are significant bends in the conduit run. Other times, cable is run in open spaces, but has to work its way around obstacles that may create tension or, even worse, try to kink the cable. A fishing scale works well if you're trying to figure out just how much tension it can actually take. Proper termination of a Cat 5e or Cat 6 cable is mandatory to maintain the performance specified by TIA 568 standards and expected by our customers. As mentioned earlier, proper cable pulling and handling during installation is important to maintain cable performance. Remember, you must use only similarly rated components on every part of the network cabling. The terminations are made with the standard IDC using 110 punchdowns or crimped RJ45 connectors. IDC stands for Insulation Displacement Connectors. Okay. What you're looking at here are the two different Cat 5e and Cat 3 images. As I mentioned earlier, you can see on the right the Cat 3 has very little to no twists. Using the punch down tool with a 110 blade, you will then punch down the cables using the cutter end to cut off any of the excess wire. Okay. The impact tool inserts the wire into the 110 block and then cuts the end off. It can be used with solid or stranded 28 to 22 gauge wire. The blades provide punch and cut, or just punch by flipping the blade over, depending on which one you're using. The extra blade is usually stored in the bottom of the handle of your punch down tool. You select the 110 blade, insert it into the tool, cut end out for performing both punch down and okay. Strip about 2 inches of jacket off the cable using a jacket stripper. Separate the pairs, but do not untwist. For each pair, untwist just enough wire to place the wire into the punch down slot. Remember, it must be untwisted less than ½ inch before termination. Some high performance cables have two wires in a pair, bonded together to maintain geometry. These cables require special splitting tools to separate the pairs. Place the wires in the slots of the wiring block in the color-coded order: blue, orange, green, and brown, with the white wire of each of its pairs first. Some installers remember the order of colored pairs as blog, the blue, orange, and green, with brown following by default. But some 110 blocks have color coding on the block itself. Now remember, the white wire of the pair always goes first. Punch down with the tool to cut side up and remove the excess wire. The next exercise that we have in here will be for doing the Category 3 cabling. Category 3 cabling is not one that I'm going to be discussing with you here just now. Category 3 cabling, actually, might as well cover it. Category 3 cabling is used for typically just for phones only. The tools required for that would be the jacket stripper, cable cutter, and a crimp tool and punch down tool. Strip off about 2 inches of the wire, untwist. Place the jacket in the special fixture, hold it securely, punch down the wire to terminate it. The termination for the Cat 3 is pretty much the same as the termination for the Cat 5, the Cat 6. The Cat 3 termination typically wouldn't go into a 110 block, as it would go into what we call a 66 block, one that we use for telephones. Tools required for that would be a 66 block, jacket stripper, punch down with a 66 blade with the cut side out. The 66 blade, it works a little bit differently as it goes over top of the IDCs as opposed to the 110 punch down, which goes inside. As you can see, this is how we do the Cat 3 for our telephone lines. And what you see on the right, and a graphic of the one on the left, is your 66 block. Okay. First thing you want to do is identify the Cat 3 cable in the training box, okay, in your box. Strip off about 4 inches of the jacket, untwist the pairs, but keep the pairs together. Following the same code as the Cat 5e, blog, blue, orange, green, and brown, always white first, punch down each wire into position on the end of the row, the block. Okay. The punch down tool works almost exactly as it did for the 110. Make sure to use the 66 blade end that says cut, so it'll cut off your excess wire. And make sure the cut side is on the side of the position that has the excess wire to be cut off. After you've terminated one Cat 3 cable to the 66 block, remember the other Cat 3 cable on the other side of the block with the color-coded wires in the same rows. Now you can use what we call bridging clips to connect the rows to complete the connection. That's another option. Now, if you want more practice doing punch downs, we're gonna put a short video up here to go in with this. But I also have for those of you who are with me physically, not just doing a video, we have a punch down block in the other room. So when we're cross-connecting our bridge clips, okay, we can the cross connection, it allows us to have one side directly connect another side, or you can use wires to do the two. So if we look back over here, you can see I can do a cross connect wire into my punch down, or I can use a clip that just fits over top. After the connections have been made, the wire mapper tests for all wire mapping faults found in Cat 3 or Cat 5 or 6. Cabling includes open, shorts, reverse pairs, cross pairs, and split pairs. An instrument display indicates the problem in the pairs as a fault. The tester consists of the instrument itself, a remote terminator, and several short patch cables and dual terminators to allow connections to either plugs or jacks for field use. To use the wire mapper to test your patch cords, you want to connect the wire mapper directly to the terminator with one of your patch cords and a dual jack or female modular pin connector. Initiate the test sequence on the wire mapper, and when finished testing, the wire mapper will show the results for a few seconds and then might automatically turn off. If it does not indicate that all pairs are correctly wired, check another patch cord or terminator, because valid testing will require properly wired patch cords and terminators. When it comes to troubleshooting, you want to look for open or shorted pairs, like we talked about in the last chapter. Okay, and we have to just have an understanding of what an open or a short is. Okay, the wire map will indicate a short where two conductors are accidentally connected. Okay, if two wires are connected, that would be a short. Right? If one of the wires is not connected, it's open. Reverse pairs occur when the conductors, tip and ring, are reversed on one end of the pair. In the example we saw earlier, the wire mapper will indicate a reverse pair. The wire mapper will indicate a reverse pair. So for 3 and 6 in pair 2, reversals can occur at any connection. So look for the correct wire color coding at every termination point. Because it involves reversing white in a color, it should be easy to find. Transposed pairs occur when both conductors of one pair are reversed with both conductors of another pair in one end. In the example, the wire mapper will indicate crossed on both the 1, 2, and 3, 6 pairs. If you see a crossed pair error involving pairs 2 and 3, it may be that the link has a mixture of A and B terminations because these two terminations differ by the reversal of those two pairs. A split pair, some wires will verify that we have some faults like split pairs that may show up in their wire maps. Split pairs occur when one wire, each of two pairs, are reversed on both ends. This is possible to find with a normal wiring verifier because the wire map is correct. That is, the pin connections are correct, but the wires are not in the proper pairs. This error can be detected usually by having a near-end crosstalk test or a balance test. Some errors are easier to trace than others. Random problems require simply rechecking all terminations in sequence. If you've got a certification tester, special cable testers, or a TDR, you can ascertain the distance to opens and shorts. And if you see a crossed pair involving pairs 2 and 3, it may be that the link has a mixture of A and B terminations. If pair 1 is reversed and everything else is in there, then you could be using a USOC for video. It could be that type of pinout. If a cable certifier is available, test your cable link with that. The tester does much more than just a wire map. It measures length, attenuation, crosstalk. And we spoke about that on Chapter 9. In summary, cables must be carefully prepared for termination. Unlike electrical conductors, telecommunication conductors need more than a sound physical connection. The conductors must also maintain their shape and layout all the way to the connector. And if they don't, the signal will distort and other problems can occur. Proper tools are necessary, not just useful, but necessary. Furthermore, practice is required. Termination in telecommunications cables requires testing and documentation at the same time of installation. That concludes our Chapter 10, Wiring Termination Practices. I hope you found this useful, and we'll see you back here again for Chapter 11, which will be fiber optics.
About this. Okay, you've got your 4-pair wire. All right, it's got your blue, your orange, your green, your brown. Usually this is referred to as station cabling if it's used for phones. If it's used for computers, then it's usually just called Ethernet cabling. But in this case, we're working with phones, so we're going to do station cabling. All right, so I've got my station cabling. You know, it comes in all different kinds of circumstances, but this set of cabling, these 2 cables come out of the ceiling. They're going to go down onto this 66 block, and the reason they're getting terminated on a 66 block is because I'll be making jumper connections from a phone system, which is over that direction, jumper connections from the station ports over to the station cabling, which will then go out and feed telephone instruments. All right, they would not feed computers. If you were doing this for cabling for computers, you would be punching down on an Ethernet patch panel, not a 66 block. All right, what I like to do is take my cable and fish it back behind the 66 block. And I like to go to the middle. Over on the side, there's like a couple of slots where the cable can come out on the side. I like to go in the middle because then I like to turn around and come back up like this, and I get to have a little tension down here in this corner, and I just kind of guesstimate about where I'm going to want to have my wire be, you know, peeled back to, and then I make my cut, or not my cut, my stripping cut about 3 inches ahead of that. I don't want to make my cut right here, my stripping cut here. The reason is because if I make a strip cut in here, I'll probably nick the wires inside, and that's a bad thing. I'm going to make my stripping cut up here. Okay, I'm going to pull back the skin like so. I'm going to get rid of some of this excess. Okay, I'm going to pull off the sheath, Now, inside most cabling, not all, but most, is usually this thing we call dental floss. This little bitty string. I don't know if you can see that on the camera. It's a little bitty string. It looks literally like dental floss. And I'll pull it back. Actually, it usually helps if you make just an itty-bitty little nick with your scissors in the edge of the cable jacket. The stuff on the outside, that's called a cable jacket. And pull the dental floss into that little nick, and it makes a nice, smooth little tearing action. And the reason that we do it this way is so that we never have to brush our scissors or cutting instrument up against the copper wires inside, because this skin, this blue, orange, green, brown, the skin on top of that copper wire is very thin. All right, so it nicks very easily. So you see how I've kind of pulled it back to just about where I'm going to want it. And then what I do is I get rid of my excess jacket. Okay. Again, being careful not to nick the actual wires inside. I'm going to go ahead and get rid of my dental floss there. All right. Now, in order to terminate these guys, I need what's known as a 66 blade. Actually, that's the no-cut version, but this is a 66 blade, okay? If what you have looks like this, that is a 110 punch blade. That's not going to work. What you want is the 66 blade. And 66 punch tools come in all different variations. This happens to be a Harris Dracon, kind of an industry standard. I've had it for, oh gosh, I've had this one for at least over a decade or more. Okay, so I got my 66 block punch tool ready to go. I'll set that down for a second. I'm going to spread out my wire. Okay, I got blue, orange, green, brown. That's the order they go. Now, I have a separate video on the wire color code that if you're not familiar with the wire color code, maybe you should go check that out. But basically, blue's going to go first. So loosen up a little twist. You know, I take some of the twist out of the wire, and I lay that across the first two pins. Now, these pins, I call these things pins. There's 4 across, and they go down, there's 50 of them. The pins have a itty-bitty little hook in them, and I don't know if that's going to come out on the camera, but I'm going to go ahead and give it a try. I'm going to pick up the camera and move it real close to where the pins are. Yeah, I don't know if that's going to show up in the video or not, but they have like little hooks on the edge of them. And what happens is the wire, when you get ready to terminate these, you take the wire and you just kind of put it on the edge of those hooks. Okay? And it'll actually, if you pull a little bit like that, it'll actually just kind of stay like that. Alright, now the right way to do this is before you start doing any punching is to fan out your wire first. So I did my blue, and now I'm going to do my orange. Now again, the color code is key here, but it's white, blue, and then solid blue, and then white, orange, and then solid orange. Okay, and then my green, white, green, solid green. Okay, if what I'm talking about with the color code is not making any sense to you, go look at the other video I've got about the telephone wire color code. Okay, that'll talk about that. You need to understand that for this to make any sense. All right, and then the brown. You know, and this loosening the slack, you just kind of have to get a feel for it. You know, it's like a lot of things in life. If it's worth doing lousy for the first few times. So it's probably going to be awkward the first few times you do it. But at the end of the procedure, what you want is these all fanned out, kind of like stuck on those hooks. And I've got, you know, white, blue, and blue, white, orange, and orange, white, green, and green, white, brown, and brown. And with the tension that I've got on them like this, I can take my punch tool, and it's got the little cutty blade there at the bottom. So, and when you do this, you want the blade. I don't know how this comes out on the camera, but in the 66 tool, one edge is flat, and one edge has got like a little knife on it, okay? Whoops, sorry. One edge is flat, one edge has got like a little knife on it. You want the knife facing down, okay? Because when you punch, your punch tool should make like that little clicky noise, because there's a tension spring inside. That knife cuts the excess wire off, okay? So these wires now, every time I'm punching, that knife is cutting off the excess that I don't need. Now, this is something that happens to you when you're doing it this way, is that sometimes as you're pulling down on the wires you've already cut, they get stuck in the hooks of the previous one. Now, in a real production environment, because this is just my lab, normally if I was doing a bunch of station cabling, I would probably fan them all out first, and then just go back and visually check one more time to make sure I didn't mess up the sequence of the wire colors, and then I would just punch them all at once. And also, I'm punching twice, or sometimes I punch once. That's just kind of a habit. Sometimes some people punch twice, some people punch once. Whatever it takes to get the job done, or whatever you're comfortable with. Okay. All right. So that is a terminated station cabling. And again, to recap, the reason I have this is because this wire goes out into the ceiling, goes across the ceiling, comes down some wall somewhere, and ends up in a telephone jack where the telephone gets plugged into. Okay? It's usually referred to as station wiring. I guess you could call it phone wiring. And so then what happens is all your station wire terminates either on a 66 or it could be on a 110, but that's not what this video is about. Could even be on a BIX, which is common in Canada. Is that this wiring is then cross-connected. So you take another little set of wires and you put them on the next set of pins in the middle, and you move them over to the phone system. So your phone system will have, like, ports 1 through 32, and then so you'll take port 1 and you'll punch down there, then you'll bring the wire over and you'll put it down on the blue pair of this. Now, normally each phone set will only get one cable, and they'll actually only use these days just one pair. There's nothing to say you can't split these up. So I mean, you could take one wire and you could put 2 telephone jacks at the end of it. It used to be years ago that typical digital telephone systems were using, or hybrid systems were using 3 pair. So you'd have to use the blue, orange, green. And then AT&T for a long time was using all 4 pair. But now that they just use one, you can kind of get away with running one station cable down a wall, but put as many as 4 different jacks on it. And you just, connect station 1 to blue, station 2 to orange, and station 3 to etc. All right, so I hope that helps dispel the mystery of terminating station cabling on a 66 block. Thanks for watching.